Good evening, everyone. This is Damian Carlson with the ProfessionalVMware.com vBrownbag US edition. Tonight we have Jarett Kulm on to speak about the CCNA-DC certification, Section 11, United Computing. A few things before we get started. If you're new here, you can always follow us at vBrownbag on Twitter. Our European show is at vBrownbag LATAM, and our European show is at vBrownbag EMEA. Asia Pacific is every other Thursday night at 10 p.m. New Zealand time. EMEA is Tuesdays at 7 p.m. British time. LATAM is Thursdays at 7 p.m. Pacific. And of course, this show, the US one, is 7:30 p.m. Central. If you have any questions, feel free to raise your hand in the webinar, or hit us up on Twitter at vBrownbag or using hashtag vBrownbag. Again, my name is Damian Carlson. I'm 6 Dad on Twitter, and our presenter tonight is Jarett Kulm. He's at JK47 The Weapon. And with that, I'll go ahead and turn it over to Jarett, and we'll get things started.
Thank you.
And you should have the ball now.
All right, one moment. Let me get this set up. Okay. All right, so I am Jarett Kulm. I'm a principal technologist with a VAR out in the Philadelphia region. I've been using UCS and Nexus really since the first generation of it being released, and it's my pleasure to help teach you all tonight. If you have any questions, feel free to put them into the broadcast, into the questions box or chat, or send them along on Twitter, and we'll answer the best that we can. All right, so did that forward? Just want to make sure it's working right.
It's back to the vBrownbag holding screen. We saw your presentation earlier, but it's not showing now.
All right, 1 moment.
There we go.
Okay, sorry about that. So I am a CCMP data center, a member of Cisco Champions and the NetApp A team. I actually have a cert for every letter of the alphabet. That was sort of like a game I was playing. And I've been in IT for a little bit over 20 years now. Now, before I start on the actual compute side of the discussion, I want to go through some of the material that we've seen before in other sessions, because there's a couple topics that I've had a lot of people talk to me about in the past when I was helping them study, or just customer environments that, especially if a network team or a typical Cisco team is running a UCS environment, there's key aspects which come up more often than not. And really it's quite often about the fiber channel piece, any of the storage connectivity. But first, I really just wanted to ask, why should you get certified? And if you want to be like my friend Anthony here, it's all about the money. Now, why did I get certified? I sort of was forced to. So my boss came up to me and said, for our Cisco partnership, we need you to get CCMP data center. All right, I didn't have a problem with that. He said, well, we need you to get it by the end of the month. That was a little bit of a problem. So I went the unusual route with my study. I searched for every blog, every document, every bit of material I could, and I typed it out 3 times. So long story short, I did get it by the end of the month, but don't be like me. Plan ahead, study a lot, and definitely make a plan for how you're going to study this. If there's anything that comes up that you don't know, I mean, definitely blogs are a great way, but Cisco has some awesome material. There's 2 books that I'll show in a few moments that I highly recommend. So as far as weird things that come up on study or in the exam, which you probably wouldn't think you'd have to know for a modern data center, I just want you to recommend study about the topologies. So it might not seem relevant in today's world, but make sure you know what a ring is. Know about old data center technologies. 10BASE-T, even though most people listening might not have ever seen it, look up what it is. And Cisco, on their exams, they're usually a couple generations behind on the products that they're asking about, and there are a lot of questions about specific models and model features. So I typically recommend look up at least 2 generations behind. Most categories on Cisco's website, it has a discontinued products list. Look there, make sure you know all the model numbers, what they did, and even some features that newer models have that older ones did not support. And also, routing protocols which you might not use in a modern data center, they very well could be asked on the exam. Now, as far as recommended tools and readings, definitely get the platform emulator. There's different versions for the C-Series type simulation or the standalone fabric interconnects, the UCS Mini, and the M-Class. So get a hold of at least one of those and work through it, build up your own environment, and then a couple links I've included which are great readings to get an overview of some of the more complex technologies. These are the 2 books that I'd recommend that you read. Really, the CCNA Data Center Guide should include everything you need. It does not. So get your hands on the NXOS switching book. It is really critical. It goes over a lot of the more advanced topics. You might not understand half of it. I've been doing this for years and years, and there's still some areas of it which confuse me, but that's what this whole process is all about. Now, you don't have to be certified to be able to use or run a UCS. It doesn't matter if an installer is just starting out or if they're CCIE. Almost every single deployment I see in the field is using the reference architectures based off of what you can find in the Cisco design zone. So here you can see actual implementations, actual certified, checked off, tested designs for every SAN manufacturer, most Nexus switch types, and all of the different UCS flavors. So I'd say look at a couple of these. Make sure you read every single one of the deployment guides. The deployment guides are actually step-by-step for everything from your SAN, your switch, and the compute platform. These range from 200 to 400 pages of step-by-step, but they were absolutely critical in me learning how to actually deploy, use, and maintain UCS environments. Now, what usually comes up by my customers who might be more network focused and they're starting to step into the actual overall UCS world, we're starting to get more blended job roles. So someone that might have previously just been a network admin, they might have to start managing the MDS, or on their Nexus they'll have to start managing the vSANs and some of the FCOE. So zoning for fiber channel. Zoning is limiting what can talk to what. So in the diagram below, I know that my top host, it's HBA1 and the SAN HBA1, they can talk to each other, but no other HBAs can see that traffic. Now, on the top and the bottom, both HBA2 can see each other's traffic and what's coming out of the SAN HBA2. So zoning is really like isolation of your fiber channel frames. It can be based on ports, so I could say my port 1.1 on my fiber switch, my port 1.2 can talk to each other, and that's it. They're the only ones that can see each other's traffic. Don't do that. That's bad form. Other types of zoning are where you actually use the node name or the worldwide port name for your source and destination. Typically, SAN vendors recommend single initiator, single target, and there's actually some ways to make that easier in newer versions of Cisco MDS fiber switches. And you can think of this a lot like VLANing or PVLANing in the Ethernet world. Now, working in tandem with zoning or LUN masking. Basically, this is configured on the SAN side, but it's a way to say this one specific LUN, this virtual disk volume, is going to be presented up, but only this one destination is going to be able to access it. So in my example, I have a LUN with a mask on it, and there's a corresponding WWN on my bottom host. Only that one host is going to be able to see that LUN. Now, I won't go through all these, but at least I wanted to show them. So if you're looking at this, you can pause it later on, start looking these up, but it's really some key definitions. These all are going to be asked about through your studies of CCNA, CCNP, and CCIE data center. Anything you do with SAN type work, these are critical with it.
Hey, Jarett, I've got a question from Graham Mitchell.
Yes. Okay.
And feel free to answer it after you finish what you're about to say. But his question is, well, actually, he says that they use just single initiator and target zoning. So he wants to know if you would use zoning or masking or both, and what would LUN masking give as an additional benefit?
Okay, so with the actual zoning style, it really is what's recommended by the SAN vendor. Most are saying single initiator, single target. Others might be saying single initiator, multi-target. So let's say I have one HBA on a host. I'm going to put every HBA on every SAN in that same zone. Really follow those best practices. Or if you have a monstrous environment, you have to think about other things like, can your switch handle that many endpoints within one zone? As far as masking, if your SAN utilizes masking, it's an extra layer of protection. Even if you do, even if you're zoning, there still might be a way to see that LUN from another box if you're not masked. It really all comes down to security. Even though you have a VLAN, does that say you don't need a firewall on a host or on a network? No, that really masking is a lot like a LUN side firewall. So as far as FCOE ports, this is just a small list of all the different specified ports for fiber channel. These are the ones you're going to come across most in a Cisco MDS or Cisco Nexus type world with UCS. So each port type has a particular use. If you look on a fiber switch and you plug something in, you'll actually be able to see the port type change within the output if it can detect it. If it can't, you might have to hard set it. But all of these are very critical to understand, and some of the best documentation is on port types are actually in the older docs. This list was pulled both out of SAN manufacturer knowledge base and out of an old Nexus 5000 doc. But really, Wikipedia or anywhere else can give very in-depth definitions for all of these. And then just one tip, if you have MDS switches that are relatively current, use what's called smart zoning. It's a way to say I have one zone and I'm putting every initiator, let's say that's my server HBAs, and all my targets. So I could have 10 SANs, I could have one with multiple ports. You put that into one zone, and if smart zoning is enabled, the the MDS will actually do the math and figure it out to say, all right, this one initiator is going to this target, and it builds that mapping of the single initiator, single target for you. So that's one of the coolest things that Cisco has added to the MDS stack in a couple of years, and it's been very helpful for me. All right, so the meat of what we were supposed to be covering today, the unified computing. So there are set bullet points like describing and verifying discovery, verifying connectivity, doing the initial setup, and then some of the key features. When you actually work with a UCS, all of these are blended together. So I can't say I'm going to do a setup without verifying connectivity. I can't really explain the key features of UCS without actually seeing UCS, because once you see it, you understand the key features of it. So what's a UCS and the fabric interconnects and all that actually look like? It's this. So this is enough hardware to have 8 blades, and then with just a couple more wires, I can expand this out to a dozen or more chassis. So the cool thing about UCS itself is it takes very little cabling from each chassis. Now on the far right, you see a full stack. We have our Nexus switches. We have 2 fabric interconnects, and then we have a UCS chassis, the actual blade chassis. Now if we look on the top left at the 2 yellow cables, those are the cluster cables between the 2 fabric interconnects. If we look at the center picture where it says 2208, those are the uplinks from the I/O module, or the little FEX fabric extender that goes in the chassis, and those go up to the fabric interconnect. So if you've never seen a UCS before, this is really what it looks like. And I've known plenty of admins who never actually saw the hardware they were running, so it's good to actually see what's plugged in. Now, as far as the IOM, or where it says 2208 with those 2 cables, those can have up to 8. So that's one single fabric. You have fabric A and fabric B, 2 different modules like that. Each of those can have up to 8, which could be up to 160 gig of throughput up to the fabric interconnect. Now, when we're dealing with these designs, like I said, a lot of people use the reference architecture. This is an image yanked straight from one of those reference architectures. So the logical construct and even some of the cable types that we might use in a typical design. So neatly laid out are a couple of the pizza box servers, the C series, and those are plugged into the fabric extenders. Fabric extenders go to the fabric interconnects, as does the blade chassis. Those go to our network switches, and then those go to our storage. So these all look very similar. It just comes down to how many cables are we running to each piece of it, or is this using fiber channel, FCOE, iSCSI, NFS? The actual storage protocols differ somewhat, but essentially they always look relatively the same. Now, as far as the fabric interconnects, these are the brains of the unified compute platform. This is where you log in. This is where you do all your configuration. This is where your uplinks to your network go, your connections to your fiber switches. Everything goes through this. It is the brains, it is the heart of the entire environment. So as far as the fabric interconnects on the market now, really the major differences are the total number of ports, or how many expansion modules you can put in it. So the typical fabric interconnect, the 6248, it's a 1U device, and it can have one 16-port expansion module, 32 ports built in. The 96, I mean, it's just twice the size. There is also a new 40 gig pair where I believe I have a picture of that. Just one of the models, it's all 40 gig. The other, it has 16 10 gig universal ports as well. So I'd say understand and know the port counts and the U factor for the fabric interconnects. As far as the chassis fabric extenders, that was the little module that goes in the chassis. Actually, two go in the chassis, one for each fabric. And most customers I see are using the 2208, but it doesn't mean they won't ask you about the other models. So 2208 has 8 10 gig ports. The 2204 has 4 10 gig ports, and previous generation, the 2104, again, 4 10 gig ports. Now, again, with the 40 gig fabric interconnect, there's also a 40 gig version of this. That won't be on the exam if you take it in the near future. Cisco is always behind in generations of their exam and hardware on it. So I would recommend knowing port speeds and number of ports, how much throughput you can get out of these. And on Cisco's site, you can get a list of all the standalone fabric extenders. There's a lot between the last 2 or 3 generations, but really you should know what the differences in them are, especially if some have a different number of uplinks, if some have different oversubscription. Know which ones are just 1 gig, know which ones are just 10 gig. And you can see here these are the 10 gig SFP Plus versions and the 1 gig. They will ask you about this stuff. And if you want to continue further with CCNP Data Center, you have to know even more about these. Really, the CCNP Data Center feels like a partner pre-sale set of exams. You have to know every little bit of detail about every single part, every product, every model number, every feature. That's really what 80% of the questions were all about. All right. Again, going through some of the products, the virtual interface cards for the blades, they can be considered MES cards. I have another slide which goes a little bit more into detail about what these do, but think of these as the converged network adapters, or the way the blade talks through that IOM to the fabric interconnect. And it can talk like both IP networking with Ethernet or fiber channel to whatever's running on that blade with these VIC cards. It sees both an Ethernet card or more than one, and it sees fiber cards, just standard ones. So I could configure a profile that says, all right, I have a blade with a 1240, and I want 8 fiber cards and 6 network cards in it, and that's what it'll present up to the operating system. These in the later ones, like the 1240s, the 1280s, and newer, they can also do boot from SAN and iSCSI boot. So if you want to see what that card actually does, it basically makes virtual circuits between the backplane, that IOM, the IO module, and the blade. Depending on how many actual ports are plugged in, how many cables are plugged into that 2208 or the IOM, that's really how much it'll enable how many virtual circuits it'll create. And the big thing about this generation of cards is it can do features like VMFX if you have VMware, and just create virtual interfaces. Now the M81KR and the P81E, these were really the first step into virtual interface cards. Very specific design. If you wanted to do direct pass-through of this card straight into a VM, these could do it. They can't go as fast as the 1200 series, but they were the same generation. They're still available now, and they might have questions asked about them. So you can see there's two different models listed here. The M81KR is for the blades. It's a mezzanine form factor. The P81E, that's the PCIe form factor. And these, like the other virtual interface card, they can be broken down into virtual devices. So you can say, all right, I'm defining 2 Ethernet adapters and 4 fiber channel cards. Really, any way you can slice it up to 128 for this style. So if you had multiple VMs and you wanted each of them to have their own pass-through 1 gig NIC, these could do it. All right, I don't believe these will be on the exam, but I just wanted to talk about it a bit. This is the 6324. It looks a lot like that I/O module, but this is actually a full fabric interconnect. Same brains as the standalone pizza box size, very similar code, and these have multiple 10 gig ports and also what they call a scalability port, or a 40 gig. That's the one circled in orange. That's actually broken up into 4 10 gig ports, and each of the ports has a different function. So the scalability, that's really Ethernet or fiber channel over Ethernet only. The 10 gig SFP pluses, those are the true universal ports where they can do fiber channel, FCOE, Ethernet, just all of the functions. So when I'm working on real hardware in my lab for this demo, this is actually what I'm going to be working on. It's what they call the UCS Mini, and this is a sample design based off the UCS Mini. With something like this, it can be a cheaper solution to purchase. So if a customer might just want 4 or 5 blades, they probably won't expand to a second or third chassis, and they don't have 10 gig infrastructure. We might go this route and plug a new SAN, either iSCSI, fiber, NFS, directly into the fabric interconnects. So they can still uplink to their normal network with 1 gig, but they have all the benefits of fast at the fabric interconnect level. Now, to install UCS, if you can paint by numbers, you can probably pull it off with the design guides and how step-by-step they get. I mean, it is seriously color-coded on a lot of the documentation. So, oh, here's a red 44. What other device has another red 44? When you're reading through and studying, don't think this stuff is too difficult for you to do in your day-to-day life. The exam asks you stuff you won't ever need to know. Just like in 20-some years, I've never once had to do a subnet conversion down to the binary level. Cisco always asks that stuff. So don't be afraid. You can do this too. All right, so as far as cabling up the UCS, when you cable a chassis to the fabric interconnects, it's really all about the bandwidth amounts you need. If you know you're going to have 8 blades in there and they're going to be fully populated VMware boxes, you might want to fill up like all 8 10 gig on on each fabric and push 160 gig through your F5s. If it's just going to be a handful of print servers and AD and that and only a couple blades, you might not need more than 1 or 2 uplinks. So with this, your redundancy is at your fabric level, so you just think about the bandwidth. All right, so prereqs before you do an install, it's typically getting your fiber channel and your Ethernet switches configured. For that, you can look at the deployment guides. It's really not needed for the exam, but for uplinks, you're doing things like virtual port channels, or if you're uplinking to a stack, you're doing an LACP for each fabric's uplink, and then your typical fiber channel zoning. So as far as initial setup of the UCS, from scratch, if you just pulled it out of the box, let me pull up a little video I made of doing it the other night. So your first one, after that that cluster cables are put in, it's very basic. Do you want to do it from console? Yes. Let's set up. Is this new? Yes. You put in the password. And is a standalone or a cluster? 9 times out of 10, actually more like 99 out of 100, it's a cluster. And you're saying, is this A or B of the pair? I actually have a mistake here. The system name doesn't have the fabric identifier. I had to rename that after. And with the UCS, each fabric interconnect gets its own IP, and then it gets a virtual IP that the active unit has. So if my active went down, that would move when the standby took over as active. That's the cluster IP address. All right, I'm pausing it here. Join centralized management environment, UCS Central. What would I do if I had a big environment and I had, let's say, 5 chassis, 10, 20. There's customers out there with hundreds of chassis, and fabric interconnect can only have so many on it, depending on how many it's cabled, 6 or 12 or so. Really, the maximum amount is based off of how many uplinks you do and how many ports your fabric interconnect has. So your overhead view, let's say you had multiple fabric interconnects, you wouldn't want to have to log into every single one to do your administration. That's where UCS Central comes into play. You log into UCS Central, and it does configuration tasks down to the lower level of each individual fabric interconnect. And then, of course, you verify. So at that point, it's saving the configuration. Right now, I'm essentially just waiting for it to do a quick reboot and apply what I gave it so I could connect to it remotely. And then once the first one is done, I am going to move my cable to the partner, to the B fabric interconnect. All right, I can log in, it's good. All right, this is the second one, B. So it's at the same spot, just powered it on and plugged in my serial cable. Notice what it says at the bottom. Installers detected the presence of a peer fabric interconnect. It knew it had a partner which was already set up. It's going to do most of the hard work for me. I entered the the password of the peer, the first one I set up. And really for the second one, all I have to do is give it new IP information for its management IP address. And just same as before, it's applying its configuration. Once this is done, it'll give me the admin prompt, and I can log in. So, now, next steps, you basically point your browser at that cluster IP address or the active Fabric Interconnects IP, and you start building profiles, lots and lots and lots of profiles for everything from how's it going to boot, how's my CPU going to be configured, how's my VLANs going to be. The key is reuse. So when I actually show a demo, you'll see that if I set my IPs for one profile or one location, I can use them for everything else. And I'm probably going to have 10, 20, 30 servers configured almost exactly the same, so I'm just going to make a template for it. All right. Now, this is what you'd see when you log in to a UCS Mini. Let me show you what a login to the full one looks like. Before the version 3.0 of code, you had to use Java, so the larger non-minis, most of them are still installed with the 2.2, 2.3, the older code, and you will have Java headaches with that. More than likely, first few times around until you find a working Java, it's not going to want to run or log you in. With the 3.0 code, they did go to HTML5 for everything except the KVM. All right, so first logged in, this is using the platform emulator for this view, and we can see that it has a couple chassis, a couple servers. Some of the links aren't working. Now, we can click in and start seeing our environment. What blades does it see? I can actually click on a chassis and physically see a representation of the blade and go in further and start clicking into all this and saying, all right, I click into this one blade and I see its information, identifier, parts that it has, inventory of, let's say, memory on this. But as far as exam study, first thing you do after this is cabled up and you have your FIs set up, absolute first, you go to Equipment, Policies, and you pick your chassis or effects discovery policy. With physical hardware, when you put those I/O modules from the chassis and cable them up to the Fabric Interconnect, in this dropdown, you're picking however many links you actually cabled up. And in a physical world, you're typically picking port channel here for the link grouping. Depending on if you're using the emulator, your configuration of the emulator might change if it's port channel or none. Now, before doing that, it might not even see your chassis in an actual install. If it doesn't see it, then what could be wrong are your port types could be wrong. Now I scroll down to my fabric interconnects, and when I look at one, I see primary and subordinate, depending on whichever one is active at that time. So right now my A is primary. That handled my login. That's handling saving everything. And B is still running and passing packets or frames or data. I just can't log into it. It's not really part of, it's not authoritative in the cluster. Now when I click on the Fabric Interconnect, I can see all the ports. If I didn't apply a license yet, only 12 ports are typically enabled. You do have a grace period of up to 180 days, but I've seen cases where a customer plugged in too many. They were more than those 12. They never applied their license. At 181 days, ports shut down, and I'm not sure if there's a way to tell which ones will, but it's been different from what I've seen. So if let's say I can't see my chassis, then I might actually have to click on a port and tell it to set it as a server port. Because really the FI thinks the FEX or the IO module is just leading up to a server. Now there are other port types. We see uplink, FCOE, appliance port. So let me show you what those are.
Hey, Jarett, I've got a couple questions when you're at a stopping point.
Okay. Yeah, you can ask them now.
Okay, so the first one is, are the FIs IPv4 only?
No, they're not. Even administration can be done through IPv6.
Cool. And the second question is, if we were to set for 2 links and needed to change it to 4, does that require reboots of the FEX modules and or FIs?
Yes, I believe it does. And what would actually trigger the restart or trigger that would be the acknowledged chassis. It wouldn't reboot the Fabric Interconnect, but I believe it would bring down all paths on that one module and then have to bring them up again in a new port channel. So just to clarify, FI would stay up, that one module would go down and come back up. And that would happen when you acknowledge the chassis.
Cool, thank you.
Yep. All right, so very important to know our port types. You see server, uplink, FCOE uplink, FCOE storage, appliance. So just some of them that we see. The storage FC port, I mean, if you plugged any of these straight to an array through Fibre Channel FCOE or appliances, something IP-based, you have to change the port type. Now, if you're directly connecting storage, you might have to switch change the mode that the Fabric Interconnect is running in. So we can see that. Let me pull it up. There's end host mode or switch mode. We can see that here. Ethernet switching mode. Do I want to enable that? Yes or no? Typically, you don't touch that. You're going to a real switch or you're going to a fiber switch, but you can do that through the FIs. Very rare use cases, but it is a possibility. All right, so what else? I want to make sure, there's a ton of information to cover all this in a very limited amount of time, so I'm going to hit on key points. Now we can see in these sections, like equipment, there's a lot of tabs up top. I definitely recommend getting the platform emulator and looking through these all, but firmware management, you can have it automatically install new firmware. So if I have a firmware package now on here, I can step through and install another one. I don't have to apply that new firmware to a server or to a module until I'm ready to. So tasks are going to queue up in these pending activities until I'm ready to say, all right, I'm rebooting this one blade now, and then in that blade's policy for firmware, I pick which one I want to use. So I can select, I can create new firmware packages or policies for every version I have on here. And you might have 2 different generations of blades or 4 different types of blades and 2 pizza box server C-series that you're holding firmware for. So really you're picking and creating policies based off of every use case. And that's really what everything comes down to. Everything you see in the menu, you're just setting a policy for that. I mean, I could spend hours and hours going through the list of what these all do. So even your VLANs are really just policies. Let me, where is it? So I can say I want to create VLANs, and then this is a vBrownbag, and then VLAN. Let's say I want to make VLAN 100 to 200. Now I can select, do I want these on both fabrics? Do I want them just on one? Do I want to configure this VLAN different on each fabric? But just to keep it simple, this is going to go on both fabrics. It's going to make all of these. So all I have to do is click on OK, and it created all those VLANs for me. And when I need to use VLANs, I'd select them from a list. These are just individual policies. Now, typically when you start with a clean slate and you're building things up, you're going to be doing things like creating a management pool of IP addresses. So when you add a profile to a blade and you want to pull up the KVM, really it's an IP connection to its management IP. So one of the first tasks, you just tell it what IPs to use. And again, this is another policy. So I'll just say 10 and 200, and I want it to make 16 because sometime in the future I might be getting a second chassis, and then give it my gateway and the DNS. So I just told it that its lights out management or the KVM IP address that it's going to automatically pull from are in this list. We can see that it's already assigned those IPs to some of the blades and hardware. Now this is a very quick, very rushed view of it. What I'd absolutely recommend is getting this platform emulator and one of the deployment guides. It doesn't matter if it's one of the FlexPod or anything, the VMware. You don't care about what software it's running on top, just that it's a deployment guide for one of the virtualization platforms, and step through every single step of building up a new converged architecture. So like FlexPod, FlashStack, vBlock, VSPlex, all those, they all have step-by-step deployment guides throughout the storage piece, throughout the switch piece. Find where it starts on the UCS and go through every single step. And by the time you do that once or twice, you'll be an ace and you'll have seen almost every aspect about the UCM and all of the tabs. Now, critical things that you really might only do once, but if you don't do them right, it'll break everything. Things like your DNS, setting a DNS server. That's under admin. You always know things aren't used very often, but they're critical when they're under the admin tab. So call home. If you have license to call home service, you set that up here. DNS. Absolutely critical is time services on here. So you have time zone management. Every single guide you read, this will be step like 2 or 3, setting the right time zone. And then adding an NTP server. All right, so it's successfully created. If I just walked away now, this wouldn't save. Even though it seems like it would, bottom right, save changes. If I add something, let's say 1, 2, 3, 4, and I start clicking somewhere else, it doesn't always prompt you that it didn't save it. Sometimes it will, depending on what you could lose, but sometimes it does not. Now, what are some of the other tabs here? Typically what people are in most often is the server tab. Once you get all your other policies set up, you have all your VLAN set up, your virtual HBAs, vNICs, you're in here with your service profiles and your service profile templates. A service profile is the personality of that computer. So if I have 50 VMware systems, I'll create one service profile template for the generic information. They all are going to share the same BIOS, the same firmware, the same bulk range of VLANs. But when I clone out a template, or when I create a profile from a template, it's going to automatically change certain numbers, like my MAC addresses. It might put the first few octets the same, but just change the last one for every single blade. So VM1 is going to end with 01. VM2 going to end with 02. So for possibly the iSCSI IPs or IQNs, the UUIDs, the MAC addresses, although those, it can use a sequential list or some other rule that I tell it to put those pooled resources into a unique identifier. So once I have a profile created, I can assign it to, let's say, a server pool. So everything in chassis 1 might be one server pool. Everything in chassis 2 might be another server pool. And I can just say, this profile goes to that pool. Pick the next available server. If, let's say, a server dies and I need to put another one in there, I basically right-click the blade in equipment, and I can decommission it, put in another blade, and assign that same profile. When it boots, everything is the same. MAC addresses, UUIDs, IPs, I mean, it looks exactly the same, because anything that's dynamic can be moved blade to blade or blade to C-series with some exceptions. So that's really the beauty of UCS and why it's so powerful is that once you set up certain things, you can just reapply them all over the place. Now,
and Jarett?
Yes.
If you update a template, will all the servers using that template also update, or are they static to the build profile?
That is actually selectable by you depending on what the actual policy is. So if I create a template, notice right here, initial template or updating template. So most times I want an updating template. If I have to change a VLAN on all my servers, let's say I want to add a new VLAN, I don't want to have to go to every single service profile. So I'm going to say this base VMware template or hypervisor template, it's going to be updating, and then if I make a change to anything under it, it's going to pass through. So show you some of the basics. You can either do it wizard-based like this, but see the drop-downs? These are already selected default policies. You can create your own policies before doing this, and they'll be in the drop-down, or at this point, you can click the Create Whatever policy, and the window will pop up just like you navigated to that one section and worked on it. So networking, same way, but notice your vNICs are on different fabrics. You're not stuck with just 2 NICs. You can have many, many more than that. So I'll show you one of my my lab environments templates. Here we can see a template for like Hyper-V VMware, my DR environment, and if today I have to work on Hyper-V, I just disassociate a VMware template from a blade and apply the Hyper-V. Because I only have a handful of blades, I just move them, I go back and forth between them. So here we can see a VMware. This one has 8 virtual HBAs and 8 virtual NICs. And I do this just so I can see different MAC addresses for different purposes and set different QoS, quality of service profiles, to them. So I can say 0 and 1 are for IP storage, and those are going to be priority gold. So my 2 and 3, those are going to be split between my fabrics, and they're going to be priority silver and just for vMotion. And each of these pairs are going to have different MAC addresses. So I know everything with 1A in the third place is going to be IP storage, and 2B is going to be vMotion, 3C is going to be my management, and then finally lowest class of data, but still it gets 30% when things are tight. That's my normal VM traffic. So any of these changes, again, I set them once, and if I ever make changes here, I want it to apply to all of my hosts that use these policies. Notice that MTUs, like this is just a recommended setting. This was actually pulled, this diagram was pulled from the Citrix 7.1 architecture guide, and it just lays it out beautifully no matter what your hypervisor is. Notice this is where you're setting your MTU. So the only difference between gold and best effort are the MTU size. Both get 30% of the resources. Same with silver and bronze. Silver is jumbo, bronze, same percentage, but normal 1500 MTU. Through QoS, you can set COS markers, and you can also set your MTU sizes. So that's one thing that for a little bit when I was first starting with this platform threw me off. Didn't understand that why they put it there, but it definitely can make sense. Let's see. Let me make sure I'm not skipping over anything. Oh, very, very critical. All over the place, you're going to see FSM. Let me see if I can pull up somewhere with it. Oh, admin. What FSM is, it's finite state machine. And it's actually very, very critical to how the system works. You'll see this box, anywhere that it might have a multi-step task or tasks that have to touch multiple objects. And this lets you monitor what's going on. So the finite state machine, it's the process internally that manages endpoints and objects. So what are objects? They could be your physical components. When you have to discover new hardware, let's say you install a new blade chassis, it's actually this FSM process which manages that. If I do a backup, it's many, many steps that it's monitoring. Server discovery, same as chassis, it's this watching it. So here we can see a screenshot of firmware management, and I did a firmware install. And we can see that just installing firmware, it's up over 20 steps. And really, firmware takes a ton of steps, dozens and dozens. But we can see every single thing it did along the way. Oh, it had to activate it on the IOMs, and then verifying the health of the peer interconnects and waiting for acknowledgement because you don't want it to update the firmware and reboot everything at once. So this is actually a really critical service. And down below, definitely watch this again, pause it, and go to that URL. It's an ugly URL, but it's very, very good data. It's a lot about the finite state machine. Or if you just Google Cisco UCS FSM, you'll get a lot of documents typically regarding the fault system, but you'll see a lot of about finite state machine, or those. Read through them. It's very, very important because this is at the heart of so many different tasks. So definitely something to look at. Also, one thing that I'm not sure if it's on the exam or not, but I've seen a lot of environments taken down because of this: power policies. The UCS has, let me pull up the picture again, it has 4 plugs, multiple power supplies in it. So this is how it knows what to handle in certain cases. You could tell it that you want it to run to the point where it can handle losses up to being able to run off of a single power supply. Or you can say grid, which is 2 sources are turned on, and then it can handle a full loss of 2. So make sure that you double check what your own environment's power policies are, because setting this incorrectly, having a 2 or 3 power supply loss may or may not take everything down. But this links to other power profiles where you can actually set limits on a per chassis or per blade basis about what actual wattage that chassis is going to get. So a fully loaded chassis, it might say, I won't let you drop this down lower than 870 watts or however many watts, but you could have a power policy in place that won't let you boot more than 6 blades, even though you have 8 populated. So that's something that very, very important to know, but I can't remember if it was on the actual blueprint or not. Now, we're a bit out of time, but there's so much more information that I could share. Hopefully I've covered everything. If you have any questions, feel free to ask, and in the final few moments I can show you more about this. But I just want to recommend get the emulator and go through one of those deployment guides step by step of a configuration.
Absolutely. Thank you, Jarett. How much longer do you think you would be able to go with this, or are you about wrapped up with your presentation?
Well, I mean, I could go through a full profile setup, or really it's however long the people online want to keep listening to it. But let me actually show you one of our templates. And
sure. Yeah, it's not just the folks that are attending currently, but also folks that'll view this afterwards. So,
yes.
Whatever you're comfortable with.
All right, so stepping through, before I even get to the point of creating a profile to apply to a server, we have our VLANs, which I showed. In this case, it's used by a lot of engineers, so every engineer has a group of VLANs. We can see that I have VLANs for management, IP storage, and that's really not the end of it for networking. We have, under that, we have to create templates for your virtual NICs. So let's say for Fabric A management, I have to tell it, all right, I want a virtual NIC. I want this virtual NIC to talk through Fabric A. And then if I want this to move fabrics in a failover, very rarely do I, but that really depends on system design. Now, do I want this VNIC template to be updating? This goes back to the question that was asked. I can do more fine grain about what I want to update. So for something like a NIC, of course I do. If I select a new VLAN, I want it to pass up through this template, through this VNIC template, up to the service profile template, and then finally up to the blade service profile. So whether it's one service profile or 100, if I make one setting here, I only want to do it that one time. So VNIC, for example, some of the aspects of it, I'm setting my MTU, setting which MAC address pool that I previously created that it's going to use. Here we can see we have a lot for different purposes. My QS policy, like I showed in that diagram. Anything you see in a drop-down is another policy somewhere else. And then here we can see my network control policy. This is just a policy saying turn on CDP. And again, it's in a drop-down. I set it somewhere else. So we can see under here VLANs. Right now, I only have one defined in this, but let's say for my VM data, let the list load. I have a lot of VLANs under my data network. And then selecting a native, if I did want a native VLAN, I just check this radio box, which would put that one as the native. So other things about networking, I mean, if you had iSCSI for boot, you'd have to create an IP address pool. You have your MAC addresses. So here we can see under my MAC address pool, really everywhere, we have this idea of a sub-organization. So what if you wanted to have multiple different groups, and you have finance, you have the kitchen services, you have, let's say you're a school, you have your administrative, you have your students. You could create sub-organizations for all of these, and all sub-organizations have the same policies, but if you set something up at the organization level, it can only that organization and those below it can see it. So it's almost like parent-child relationships. If I have something defined at the upper layer, then a lower layer's organization can see it, but not vice versa. Sibling organizations can't see each other's configurations. So for my MAC address pools here, at my root level for MAC addresses, I just have a default set. But for a sub-organization, I have a lot of others set. So here we can see one of the blocks that I created. And really when I create a new one, I just told it that was what I wanted it to be at the start and how many to make, and it made the rest. So I'll show you how it does that. Sequential creation is your friend. So for things like MAC addresses, WWNs, anything that might be tied to a fabric, always note which one you're creating it for. It'll help out in the drop downs quite a bit. So if I wanted to create a MAC address, the first three are basically like the burnt in. Don't ever try to change those. And then these you can change. So I'm going to say for this one, I'm making it 1, 1, 2, and then AA. And then for size, let's put it 16. So it's going to build that out. And when I assign this to either a VNIC or eventually that VNIC goes up to a service profile template up to a service profile, it's going to pick the first one available and assign that to that blade in that service profile. And then second one I create a service profile off of, it'll just keep going down the line. So when you're building these up, you're just thinking, what might I want to change? What do I need to do? That's why those reference architectures and the deployment guides are so handy. Is there's so much that you can configure. It's very easy to forget or to not do something. So typically, like bare minimum things you'd want to do as far as templates. I mean, you're talking about making a disk configuration pool. Do you want disks or not? Which relates to how is it going to boot. So it could be SAN connectivity. You need a SAN connectivity pool, or your actual policies about. Your SAN connectivity policies, boot policies, MAC addresses, UUID. If you're doing fiber channel, then you need your WWNNs and WWPNs, and then your VHBAs if you're doing fiber, and your VNICs. So that's like bare minimum, but you can go to so many different levels with this. So once you have those created, I typically jump from LAN to SAN if I'm doing any sort of FC or FCOE. Once you set up your vSANs once in most environments, that's the only time you're ever going to do that. You aren't adding vSANs as often as you're playing around with VLANs. So in this environment, because I'm doing zoning, I really just have bigger vSANs saying, all right, Fabric A, everything's under vSAN 199. Fabric B, everything's under vSAN 200. Now, not every company is going to do that. Some, because of regulations or requirements, they're going to break it out further, or they just might have many more devices or more upstream, so they'll need a vSAN for every MDS, every fabric going to a Nexus for FCOE, or this or that. So complexity or size can definitely lead to more configuration here. For fiber channel adapter policies, these are all pre-created, I believe. I'm not sure if Windows Boot was pre-created, but the other OS ones you see were. And I've never had to actually create one. So there's some things here that the defaults are fine, so you never work with anything but those. Now, VM tab. If you had something like the the VMware 1000V virtual switch, or you had a connection to SCVMM, that's where you do configurations, and when that's set up, you would actually be able to see things like what's on your distributed V switch with the 1000V, or what VMs are on what blades. I don't have that set up. In all the customers that we've worked with this on, I personally have never had a request to set that up for any of them. It definitely has some benefit. Just most aren't. Most customers don't want to do that from what I've seen and in our market or region. Storage, this tab might not show up in some versions of the PE or older versions. Storage policies at this level are quite new. So I'm not sure exactly when this came in, but it's like if you wanted I believe this is for complex RAID configurations or stuff like that on the C series. I could be wrong. I've never actually had to work with this one, and I don't remember studying about it for any of my certifications. I haven't seen this in any of the deployment guides actually being used. And if I had to actually do anything with RAID controllers in C series, I jumped into the controller's BIOS to do that 9 times out of 10. All right, so I think you all get a feel for the policies, what they can do. Like, let's say I wanted to change something in the BIOS. We can do that here. Typically, just think of this as that blue Phoenix BIOS screen or whatever one you want to think of, and every single setting there. If I didn't want to see all the data being displayed on boot, I just click Enable for the quiet boot. So there's a ton of stuff here. Typically, you're not doing a lot. It's almost like set it and forget it, or you cheat and use a list of something, a setting once, and that's what it always is. But if you ever have to make changes here, processor and memory are the places that you're typically having to do it. Do you need to turn on or off Turbo Boost? If it's a VMware environment, are you disabling speed step or hyperthreading, things like that? Those quite commonly are changed, or disabling or enabling VT to force it on. Notice platform default. Those are our best guess that are almost like burnt into the Blade or the C series, and usually they're good enough, but I mean, there are specific cases where I've had to change those. These settings, the processor C states, those I almost always tune just to what either certain VMware deployment guides or Citrix deployment guides will say, or even Hyper-V. I've had terrible Hyper-V problems if I didn't manually set C states and I just left it platform default. So those are areas where you're going to want to look. And then memory configurations under res memory. 9 times out of 10 will probably be max performance, but there might be cases for other settings. So typical settings you see in all BIOS, and then extra ones that are very obscure and typically only under TAC or hypervisor manufacturer do you ever touch. All right, so I'm going to actually create a template now. So I'm going to make this an updating template. My UUID, I'll use my demo pool. Now, none of my blades have discs in them, so I'm going to select this as SAN boot. Now for my dynamic NIC configuration, let's see, I'm going to set a specific one. Actually, I'll leave it at default. I won't actually be connecting to the network on this. So notice that once I set everything up once, I really can just almost next my way through this. So for things like HBAs and NICs, where it says placement, it's almost like which PCI slot would you put it in on the box. Typically, you let the system perform placement, but you can actually assign the order of where it'll be. So server boot order, that calls to a boot policy. Just like in a BIOS, you can pick what you want to boot. So do you want it LAN? Do you want it to actually be a remote CD-ROM, like if I had the GUI up with a virtual CD mounted? Do you want it to be a USB stick? Now for SAN boot, it uses the virtual HBA, so I'm going to tell it FC0. And once that's there, I can pick, or let's set the target. I can pick like a boot WWN and a LAN ID. So with that, that's all I'd have to do to get it to fiber channel boot off of a SAN. So let's say in the case of one of my blades, I think I have a LUN there, but nothing on it. I do like 200. It's just as an example, just whatever the WWN of, or WWPN of one of your SAN's fiber channel HBAs were. And then you can, let's say it's a multi-controller SAN. This one might be on one of the controllers, and then I can set up as a secondary on, like, same HBA but on the second controller if it's a multi-pathed, and it'll try one, and if it can't get to that one, it'll try the secondary. So I have a policy where I have multiple VHBAs, like FC0, FC1. They're all pointing to different HBAs across multiple controllers, and it's just going to try them all on boot. You can do iSCSI or more ways to do virtual media.
Hey, Jarett?
Yes.
Are you able to pass one of the fiber channel HBAs to, let's say, a Windows guest if the blade is running VMware?
Doing it for RDM is a little bit different than a full pass-through, so it really would depend on if you wanted to do a PCIe, like a PCIe level pass-through directly into the guest, where the guest sees the PCIe card as local. For something like that, you need like the M81 card, and for like VM direct path. If you just wanted to do RDM, because the VHBA shows up just as a normal fiber channel card, you can do whatever you want with that, as you could do with like a typical QLogic 2562 or Brocade, whatever, Emulex, just like in like 1200 and 12001, just whatever a normal fiber card can do, that's what you can typically do. So you could punch an RDM through, or if you do have one of the appropriate cards, it depends on the card model, it can do VM direct path and pass through one of the specific HBAs through, I guess, VMFX. I believe VMFX would do that for VM direct path. So yeah, those are the two ways. Don't usually see that too much doing an actual punch through of fiber, unless you were doing something like tape drive controlling in a VM. But if it was my customer, I'd recommend things. That's one thing not to do in my world. Not saying it won't work, but why overcomplicate things? Hopefully that answered the question.
Well, if IT wasn't complicated, it wouldn't pay as well.
Very true. But yes, there is a way to do that. It just depends specifically on the card, if the card can do VM direct path for the fiber channel piece of its CNA. So this part of the service profile template where server assignment, I can actually say I want it to pull an available server from a pool, and I want it to always be up or power on. So I'll just, actually I won't assign this, I'll assign it later, but I do have that option. If your mandate is every new blade, because this UCS environment's for VDI, every new blade goes into one pool, like my VM infrastructure pool, this makes it really easy. And then you can set or add firmware packages on specific need. If this was a blade for Oracle and you knew that because of the compatibility matrix of Oracle, of your SAN, of this and that, you had to have one specific build, because I've had that before with multipathing. I had to have one specific firmware, one specific OS driver, that's the only thing that worked, and anything else would blow up. You could create a firmware package just for that and say, pick anything else and I'll kill you as the package name. And this one blade or this one template, that's the only thing it would use, even if it was older. Operational policies, BIOS configuration, all my VMware hosts are typically the same. All these I typically don't set. Like the management IP, it auto-selects some of this. Like I only have to do KVM access typically, and it grabbed that IP address already, so I don't need to overwrite it. Power control policies, this is if you wanted to set specific wattages on servers, or is this going to power on, or is this one going to be one of the ones kicked to the curb if I lose 2 of my 4 power supplies. So I created that template, that service profile template. Let me close this one. So I have a vBrownbag template, and it's updating for everything under it. Any other policy change that this relies on, it's going to pass up through. And what I can do is I can create a service profile from this template. So I'll just call this VM, and then I'm going to start with 1, so at the end of this it's going to be 1. I'm going to create 4 of those. So this can do however many you want, but I just created 4 service profiles for 4 different servers, and they're all tied back to that template. So you have the template under it. So Any changes I make to that template or anything that that template relies on will also make a change within these service profiles. Do it once and it'll apply everywhere. So right now all of these are unassociated. Now I can change that if I wanted, and I can pick a slot or a specific server or a pool. I'm going to pick a specific server, and this is showing me that blade number 4 is free. And that was just warning me that I have more profiles essentially than I have my blades. So this actually needs to spend some time to reconfigure the blade, but I mean that's what it's going to do on first boot. Essentially wipe any personality that might be on there and apply this. So it's going to apply the Macs, the UIDs, all that fun stuff. And then we can watch what it's doing. So, again, whenever you want to watch specific details, you look at the FSM, the finite state machine, and we can see everything it's doing. So look at all that. It's really doing a good wipe. It's sanitizing any NVRAM or config it has, and it has to go through this list. And the list will actually grow as steps are completed, or as its state changes. Now notice up here, fault summaries. Depending on the stage of a reboot, these might change, or what's going on at the time. If you reconfigured something while it's reconfiguring, this can look like a blinking Christmas tree. So we can see that, all right, seven low priority faults. What's going on? We can see check IP, or the VM is unassociated. I mean, as things boot or as things get created, these are going to change. You can acknowledge them down below. Let's see how this is going. Oh, the WWPN, there's not enough of them, so it can't boot. So I could add another block to that pool, or I could associate a new pool to it, and it would come up. Now, if I wanted to debug that, you can SSH to your UCS, and you can debug things from in here. So if I was just hunting things down, let's say someone said a blade had a memory issue, showing you something that happens quite often, I could actually jump to a specific blade and then start doing troubleshooting on it. And if ever you open up a TAC case, I mean, they're going to send you a list of commands to run from SSH or from the serial. Rarely do they ask, what do you see in UCSM? What do you see in the GUI? They'll want either a full tech support dump or the output from these commands. So I'm at the scope of a particular server. So I can do things like I can set my scope to be a specific adapter or a fax if I had one on here. Service profiles you can see. I can actually go even deeper Let's use server as the example still. Let's show my system firmware. Okay, it's this version. There's a whole lot more firmware than that. What else can I see? That's where it all is. So, tons and tons of information that I can show you. All right, I want to see my fault, and these are some of the things it found on boot. Hey, it's missing disks. Well, no kidding, and I didn't tell it to boot from disk. So that's informational, not too bad. We can see the log capacity is low. Now, if I wanted to check even deeper into the hardware, I could connect into the SIMC. This is actually jumping into the firmware essentially and getting a ton of information. Or I could look at the sensors. So when you're doing troubleshooting, for things like blades or adapters or any of that, you're typically jumping into the scope of that device. If you're trying to figure out what might be wrong with, let's say, fiber channel or connectivity or any of that, then you're doing something like connecting into the actual OS of the fabric interconnect itself. So here I can see all the fabric logons that this has done and which vSAN it's done. Or I forget which port channels I have set up. What else might you need? Licensing, I mentioned it before, is critical. If you have more than 12 ports and you forget your license, so 120-day grace period. If you go past it, ports might just go administratively down, or features might stop working, especially like on the UCS Mini, the 40 gig port. They call it their scalability port. It's actually licensed. If you plug it in and you use your grace period, it may shut down. Let's see. So think of the FI as far as troubleshooting. If if you're connected at the NXOS level, treat it as like a glorified MDS if you've ever worked on those for a lot of your troubleshooting, especially if it's FCOE or fiber channel debugging. Did any other questions come up?
No, sir.
Okay.
You've done an excellent job. Thank you.
All right, thank you all. If you have any questions, I'm always willing to lend a hand. Quite often on Freenode, IRC, and Cisco, or you can shoot me a tweet. If you think I said anything wrong tonight or incorrect, definitely let me know. A lot of information, a lot of talking quick. So I'm not above saying I might have said a wrong word or said something off or maybe confusing, so definitely let me know. We can discuss it, and I just want to make sure that you all are well on your way to passing the exam, and if you do take it and you pass, definitely include me on a tweet about that, because I'd love to hear.
Absolutely. It's always great when you see those. I've seen a couple of them over my time with the vBrownbag, and it's always really rewarding. So thank you very much, Jarett. I appreciate your time, and thank you for everyone else. Again, we will see you next Wednesday night at 7:30 p.m. Central. And you guys have a good night. Thank you.
Thank you.